If you already joined the data mining class, I guess you know about this term. Yeah, in the terminology, there are two terminology. We call it similarity, or sometimes we call it dissimilarity or distance. So the similarity means numerical measure of how alike two data objects. If the value is high, then the objects are more alike. The similarity often falls in the range of 0 and 1. The other term is dissimilarity. We call it sometimes as a distance. It's a numerical measure of how different two data objects are, and lower when objects are more alike. So if it is nearby 0, then the distance is small, or it is almost similar. But if the distance is high, we call it the upper limit varies. The upper limit can be 1, can be 10, can be 100, can be 1 million. Okay, it depends on the data. So the upper limit varies about the distance. So proximity refers to similarity or dissimilarity. And we are going to learn about the similarity and dissimilarity. Some of the methods like cosine, Jaccard, Pearson are some important similarity measures in the recommendation system. So, this one. So in the concept of the data mining, we have the Minkowski distance. Okay. I think I have some issue with this one. Let me check it. So the Minkowski distance is a popular distance measure. And this is the general formula. We want to know the Dij. I means a data and J is another data. And we want to subtract the data. So xi1 minus xj1. And then we have the h. So h is the order, or we call this is the LH norm. Usually we have these properties to indicate the distance. If the ij, after we do the calculation, it should be higher than 0. If the distance should be higher than 0. If the number is 0, it means the data is the same. So I and I, it means the data is the same. So the distance is 0. But if the data is different, I and j, then it will be higher than 0. Or we call this is the positive definiteness. It means there is no negative distance. Dij equals to dji. This is symmetry. And triangle inequality. If we have the distance from ij, for example, like this one, if the distance from I and j axis, so there will be a distance from I to k plus the distance from k to j. So the distance from I to k and k to j. So it is, we call it as the triangle inequality. A distance that satisfies these properties, we call it as a metric. Okay, so this is a distance metric if the properties apply. So this is the special cases of Minkowski distance. It depends on the h. H means the norm. If h is 1, then we call it Manhattan distance. Or sometimes we call it as city block. Or sometimes we call it as L1 norm. Can I put the annotation? This is whiteboard. This is not whiteboard. Oh, do I? I don't know how to annotate this one. Okay, anyway, I check later. So the second one is H2. H2, we call it L2 norm. And sometimes we call it as Euclidean distance. The other H is infinite, or we call it supremum, or this is the L max norm, L infinite norm distance. So this is the maximum difference between any component attribute of the vectors. So if h equals to 1, then you can put here is 1, here is 1, here is 1. Then this is the formula. If h equal to 2, it means we have the square root. And we will do the square for every subtraction. If we have the supremum, means we will check the maximum between two values. Just for example, we have Alice, Bob, Charlie, and Dave. And those four users, they watch two movies, Toy Story and Iron Man. So Alice gave rating 5 to the Toy Story, and Alice gave 3 to the Iron Man. Now I want to know which user are the most similar. Okay, then we can check based on the distance. If the distance is nearby 0, then it means they are similar. Okay. So using the Manhattan distance or L1 norm, you can see this result. For example, let's use the whiteboard. Can I? The user 1 and user 2. So how can we calculate this? The user 1 is 5. For the Toy Story, and the user 2 is 3. Then we will do the absolute and then plus the 3 minus 1. So it is 2 plus 2. Then we get 4. So this is the distance between user 1 and user 2. What about the distance between user 2? We can just apply the triangle matrix. Okay. So we do not fill the upper side. We can just fill the lower side because it is the same. So this is the L1. What about the L2, Euclidean distance? If L1, we put the absolute, but in the L2 norm, Euclidean distance, we put the square. So 5 minus 3 square plus 3 minus 1 square. And then we will do the square root. So 2 power of 2, then it is 4 plus 2 power of 2, this is 4. And then again, we will do the square root. Then it is the square root of 8. The square root of 8 is 2.82. So this is the same. The distance. Now, what happened to the supremum? For the supremum, we want to check the maximum. Okay, how to check the maximum? Again, we still need to do the. So if we do with the supremum, we want to check the maximum. The maximum of the data on the I minus the data on the J. In this case, yeah, we will do the where is the there should be the annotation. I cannot find it. Ding ding ding. Anyway. So in this case, if we want to check the distance, okay, 5 minus 3. And then we want to check with the 3 minus 1. So my 5 minus 3, it is 2. 3 minus 1, it is 2. So we want to check what is the maximum. The maximum between 2 and 2 is, yeah, just 2. So that's why we will put the distance as we will put the distance as 2 between user 2 and user 1. And so on. Okay, so you can try to measure based on this data. Now, if you look at this one, then who is the user? The rating. Okay. Cosine similarity. So after Chuseok, we will do again this cosine similarity, but let me just explain a little bit about the cosine similarity. So cosine similarity is a measure of similarity between two non-zero factors defined in an inner product space. Non-zero factor means if we have a factor, then the value should not be zero. If the value is zero, then we cannot have the cosine similarity. So there are many applications. We can use it for the information retrieval. This many cases for text, and then biologic, and then gene feature mapping, and etc. And usually the data format is in the factor of document or some kind of factor objects like gene features, microarrays, and etc. So the cosine distance, it is a measure to check the angle. Okay? We call it, this is the cosinus. So the item 1 is here and the item 2 is here. So we can use this formula, the multiplication of A and B, and then we do the summation divided by the square of value of A and the square of value of B. So for example, a document can be represented by 1,000 of attribute, means 1,000 of this one column. When we have a lot of columns, it is for the value will be very, very biased. So let's see with this example. I have a review. Let's say this is a review from one product. In hockey, the team's consistent effort leads to win, while soccer teamwork plays something. And then based on this data, we want to check the frequency. So let's say this is document 1. In the document 1, the word team. Okay, so the word team, we have 1, 2, 3, 4, 5. Okay. Teamwork can be considered as team. So there are 5 words of team. What about coach? Okay, there are no coach here. Hockey. So we have 1, 2, 3. There are 3 hockeys, and so on. So this is the factor for the document 1. Let's say we have another document 2, document 3, document 4, and we have the frequency. So we can calculate this one with the cosine similarity or the cosine measurement. So the way to measure the cosine similarity is like this one. We have the value 5 on the word team and the value 3 on the word team, and then we will multiply 5 multiplied by 3, and then this 0 and 0, 0 and 0, 3 and 2, 3 and 2, 0 and 0, 0 and 0, 2 and 1, and so on. So we will calculate for all the attributes. So we have the D1 dot D2. The result is 25. And then we will do with the D1, or this is the square or the length of D1. It is 5 square plus 0 square plus 3 square plus 0 square, and so on. And then we do with the power of 0.5. Do you know what is power 0.5? It is the square of the length of T1, and then we do the square root of the length of T2, and we got this value. So we can just apply with the formula 25 divided by 6.481 multiplied by 4.12. Okay, we apply this one. This is the 25 divided by 6.4 multiplied by 2.5. And we get the cosine similarity is 0.94. Then if we use this one, the value is high. What does it do? It is similar or different. Similar. Why? The idea is cosine similarity. In the similarity, if the value is nearby 1, then it is similar. Okay? If it is 0, then it is different. So you need to check again based on the basic definition. What is the definition? So there are other kind of Jaccard similarity. In the Jaccard similarity, we want to measure the similarity between two sets of data to see which member are shared and distinct. So we have A is a set 1 and B is a set 2. So this is A intersection B divided by A union B. And this line means the length or how many items. So for example, this data. Okay. The user 1, let's say the user 1 have 3 shoes. The user 1, maybe, yeah, he bought 3 shoes, he bought 3 shirts, and then he bought 5 watch. The user 1 bought 3 glasses, 0 jacket, and 1 belt. The user 2, he bought 0 shoes, 2 shirts, 1 watch, 0 glasses, 2 jacket, and 3 belts. Now we want to check the similarity between each of the users. Okay. Whenever we do with the Jaccard similarity, the frequency means the number, the exact number. If we use the cosine similarity, we can use the frequency or the exact number. But for the Jaccard similarity, we can treat the utility matrix. So this is the utility matrix. Okay. We treat the utility matrix as boolean. Do you know what is boolean? 0, 1. So if exists, then it is 1. If not exists, 0. So we put 1, 1, 1, 1, 0, 1. 0, 1, 1, 0, 1, 1. 1, 1, 0, 0, 1, 0. Then we can calculate the Jaccard similarity between user 1 and user 2. So how many data are intersect between user 1 and user 2? Shared. Okay. There's 1. So this data intersect. What's this data intersect? And belt. This data intersects. So it means there are 3 data and how many data do we have? We have 6. Why 6? This is the union between user 1 and user 2. It means we know this data, yeah, we have the user 1, 1, 2, 3, 4, 5. The user 2, we also have 1, 2, 3, 4. Okay. But if you look at this one, 0 and 1, 0 and 1, 0 and 1. So it means we have 6 data, and 3 of the data are intersection. Now, let's check about the Jakarta user 2 and user 3. User 2 and user 3, we have only shirt and jacket. So it means there are 2 data intersect. But why we have 5? Why do we have 5 here? What about the user 1 and user 3? The user 1 and user 3, okay, we have 1, 2, and the remaining is not intersect. So we have 2 out of 6. Okay, you can check the user 1 and user 3. So this is the Jakarta similarity between 2 users, and we have the 3 users data. We have that in the dice coefficient. This is the measurement. Okay. 2 multiplied by the intersect data. This is x intersection y. And then we will divide with the number of data in x plus the number of data in y. So the closer to 1 is better. Okay, so this is the concept of similarity. Again, we can treat the data as a boolean. Boolean means 0 and 1. And okay, let's try to compute the dissimilarity between each pair of the items. The dice of user 1 and user 2, you will see here, 2 multiplied by the length of user 1 and user 2 which intersect. User 1 and user 2 intersect means, okay, shirt, watch, and belt. So 2 multiplied by 3. Okay. 2 multiplied by 3, it is 6. And then divided by the length of user 1. The length of user 1 is, this is the data that the user 1 have. How many data do we have here? 1, 2, 3, 4, 5. Then the length of user 1 is 5. What about the user 2? 1, 2, 3, 4. So 5 plus 4, it is 9. Then the dissimilarity between user 1 and user 2 is 6 over 9. What about the dice between user 2 and user 3? So user 2 and user 3, the intersect is this one and this one. So 2 multiplied by 2, the result is 4, divided by the number of items in user 2, 1, 2, 3, 4, and the number of items in user 3, 1, 2, 3, 4. So 4 plus 4, it is 8. And the dissimilarity between user 1 and user 3 is 2 multiplied by user 1 intersection user 3. So it is 1, 2. Okay, only 2. Oh, 1, 2, 3. Okay, so 2 multiplied by 3, it is 6. And then the number of item in user 1, 1, 2, 3, 4, 5. And the number of item in user 3, 1, 2, 3, 4. And we get 9. So this is the dissimilarity using this formula. There is another concept of similarity. We call it the Pearson correlation. If in the statistics, yeah, we can use this Pearson correlation to find whether two data, they are highly correlated or not. So this Pearson correlation measures the strength and the direction of linear relationship between pairs of continuous variables. So continuous variables means numeric data. So this is the formula. If we want to get the similarity between A and B, so we need to check, yeah, this is, let's say, rating R, A, comma, P. So it is a rating of user A on the item P minus by the R bar A. It means this is the average of user A ratings. Multiply by the RBP. It is the rating of user B on item P minus by the R bar P. It is the average of user B rating. And it will be divided by the square root of sigma RAP minus R bar A square multiplied by the square root of RBP minus R bar B square. Let's see with example. So we have the user item rating matrix. Okay, in the first of this material, we learned that we can make this kind of matrix. The user 1 give rating 5 to the item 1. The user 1 give rating 3 on the item 2, and so on. So we can check the similarity between every user. Now let's check how we can measure the similarity between user 1 and user 2. At first, we need to calculate the average. The average rating of user 1, or let's say this is RA. So 5 plus 3 plus 4 plus 4 divided by 4. Then the average is 4. What is the average of rating from user 2? Or we call it RP. So 3 plus 1 plus 2 plus 3 divided by 4. Then the rating average is 2.25. The average of user 3 rating is 3.5. Okay, so you can use it for later. Now I want to check the similarity of user 1 and user 2. Then okay, I cannot write here. So in order to find the similarity, we need to check of every of this rating minus by the average. Multiply by 3 minus by the average. So that's the upper side. And then we will divide with 5 minus RA per. This is the average of user 1. 3 minus RA, this is the average of user 1. So this is the rating from the user 1 given to item 1. This is the rating given to item 2 from user 1. This is the rating for item 3 given by user 1. And this is the rating item 4 given by user 1. And then we do the square root, multiply by the square root of, this is the rating from user 2. And we will get the value 0.85. So please check later whether it is correct or not. Okay. And users are the most similar. Because this is the similarity, then the closer to 1 is the most similar. It means user 1 and user 2. Okay. Now, my question. Some examples with negative value. So there are many. If you have interest on this domain, you can check. Okay. So for example, there are some other similarity measure like PCC, CPCC, PIP, and so on. Okay. This is a model for okay. Can you mention the difference? Do you still remember? So you can check on this one. Okay, Manhattan distance, Euclidean distance, and supremum distance. Okay, we have a matrix. So we have user A, B, C, D, and we have items A, B, C, D, E, F. There are some missing values. If there are some missing values, and then try to measure the Jacob similarity, cosine similarity, and dissimilarity. For the Jacob and for the dice, you need to turn the utility matrix into Boolean. So after you turn this into Boolean, you can measure it. But what about the cosine? In the cosine similarity, you can just use the value as it is. Okay, so please try at home. We will discuss it in the next class for this one. Okay. Okay, let's have a break. Okay, I will continue after the break.